Hello. So here we are again doing a CodingBat video, and we're given an array of integers, and we want to return true if the array contains a 2 next to a 2 somewhere. So essentially, the idea here is to first, of course, if we want to look at each and every element in a given array, we want to use a for loop to traverse the array and actually reference the index as the variable I, which is actually in the for loop parameter, increments by 1, so that we're referencing a new index each iteration, such that we're actually looking at a different element each time. So the way this works is we can use, so we have a for loop, right? I is less than nums.length, and we want to increment I by 1. So I'm doing this just because we're operating on the basis of first principles. That is to say that we're doing what we know for sure, absolutely. But it would be a better idea if we were to start off with some theory. So theoretically speaking, in terms of pseudocode, we would first want to have a means by which we can sort of look at each element one at a time. And once we've, and of course we know that this is, we do this with the for loop, right? And once we've sort of done that, looked at each element one at a time, we also want to sort of have a condition as we traverse. So we must have a condition as we look at each element. This condition is if any given element on any given iteration is equal to 2, then we check if the next element, or rather the element next to it, is equal to 2. If it is, we return true. If it is not, we return false. So we're looking, and so we're just assuming that we're looking at these indexes, right? And what I want to note here is I just want to have these 3 boxes. This is an example. So when you create an array, or when you're given an array, you essentially just have these 3 boxes, and each of these boxes sort of can hold. They can potentially hold elements, which is of course data. And for each box that we have an index. And the index count starts from 0 and works its way up. And so I, in the for loop, I is essentially just a reference for the index. And as it increments by 1, it essentially keeps, it goes from 1 to 2 for the length of the array. And it will look at each element as it's referenced by the index in question. So as we look at each element, or rather as we reference the index, which actually allows us to look at the element one at a time, we're going to check if that element is essentially if what we do is we call it nums of I. And so this references the array, and this references the index. So if I wanted to access the second element, I'd actually have to go through the first index. So I would say nums of 1. And I say nums of I because I, each and every time, it increments by 1. And so I'm allowed to access the entire array one by one. So I'm looking at nums of I, and I'm saying, okay, if nums of I is equal to 2, then I want to go ahead and make another decision. So I said, okay, this condition is if any given element on any given iteration is equal to 2, then we check if the element next to it is equal to 2. So here, what I've done is I said, okay, if any given element is equal to 2, then check, right? So this is what, then do something, right? If any given element is equal to 2, then do what's inside here. What should be inside here? Well, if any given element is equal to 2, we want to check the next element and judge whether that is equal to 2 as well. And if it is, return true, else return false. So we know this because this is, of course, in the problem statement itself, or rather the pseudocode that I've written up here. So if nums of I is equal to 2, we will check if we will increment I by 1, and we will check if nums of I, we'll check if nums of I is equal to 2 now. And if it is, we'll return true, else we'll return false. So essentially what this is doing is it's saying, okay, if nums of I is equal to 2, return true. No, it's saying that as you iterate through, if we come across any given element which is 2, for instance, nums of I is 2, or nums of I is 1, so we're looking at the first index, so we're actually accessing the second element. And as we do that, nums of I is 2, and so we come in here and we say, okay, now that nums of I is 2, we want to check if the element that comes directly after it is equal to 2. And so what we do is we know that I is keeping track of the index. So right now I is 1 because we're on the first element accessing the second. We're on the first index accessing the second element, but it's not actually the first index. It's the second index, but we're calling it the first because it has the number 1. And so now we increment I by 1. And so now instead of being I was 1 before, instead of being 1, it's now 2. And so we're looking at the second element now referenced by the second index, which is of course the third index in a sequential sense, but in the sense where if we're working with numericals here, it is the second index. And so we increment I by 1, and now we're checking this box. So if this is 2, then it's going to come inside here and return true, otherwise it'll return false. Now, what I want to note is that there's this famous edge case. And the edge case is, suppose we had, this edge case comes up very often with arrays. Suppose we had something that looks like this, right? So it looks, it doesn't find anything here. It doesn't find anything for 2, so it doesn't go inside this block of code. And then again, as I becomes incremented by 1, it looks inside this box. It doesn't find anything, so it doesn't come inside. It doesn't find 2, so it doesn't come inside this block of code. And then it looks at the third element and it finds 2. So it comes in, and so it says, okay, I is equal to 2, num sub I is equal to 2, num sub I is equal to 2. And so we come inside this block of code and we increment I by 1. We're here at the second index, and we increment I by 1. And so now you'll see that the index has been added, and that becomes problematic because now we're referencing an element. We're referencing an array which is outside of the length of the array. And what I mean by that is the length is 3. There are only 3 boxes, but essentially when I increment I by 1 and I tell it to look at that element doesn't exist. We're walking off bounds of the array. And so that becomes problematic. And so if we do, so in order to understand this, let's actually understand why we have this here, I is less than nums.length. We have I is less than nums.length because at any given point in time, we understand that the length of the array, whatever it may be, in this case it's 3, and then our index goes from 0, 1, 2. So we have this relationship here between our index and our length, in that our length is 1 more than our index, or our index is 1 less than length. And so we leverage that. We say, okay, fine, keep incrementing I by 1 so long as it is less than the nums.length. So keep looking at these elements so long as I is less than nums.length. And I must be less than nums.length. That's when when we're on the third element, which is the second index, which is 2. 2 is less than 3, and so now we stop iterating. We're at the end. We don't do any more. But if I increment the index, then we walk off the edge of the array, which is not a good thing, and we get an error. So, but if I do so I never want to walk off the array. I never want to walk off the array. So if I do I is less than nums.length minus 1, essentially what that does is it only iterates for, so if you think about it here, int I is equal to 0, so we're looking at the 0th index. We're looking at the first element, which is 3. And then we look at I increments by 1 again. We're looking at this, which is the second element, which is referenced by the first index, which is 1. And then we come here, and it will only iterate for i's less than nums.length minus 1. So the length is 3. We only iterate twice. So we're only iterating here. This is where our iteration stops. But you'll notice that the I gets incremented 1 more after the loop is done executing. And so that brings us to our last index, but it doesn't go any further. And so doing nums.length minus 1, or the array name.length minus 1, essentially allows us not to walk off the edge of the array. So if we're incrementing by 1, always make sure to essentially not walk off the edge of the array. Or in order to make sure you don't walk off the edge of the array, just do your array.length minus 1. But of course, this is only if you're incrementing by 1. If not, then there's really no problem. So that's one thing to consider. Another thing to consider is, if I actually run this, it's going to say that, let's see here, oops. It's going to say that I don't have a return statement. That's because after it's all said and done, I actually have to return something at the end. So instead of saying return true or return false, it would be better if I had a Boolean variable called, let's say has22 maybe, and set that equal to false. And if, of course, we're inside this block of code, has22 gets set equal to true, otherwise has22 is equal to false. But I don't really have to, I don't think I have to clarify. I don't have to specify. And we can just return has22. I don't think I have to, oops. We're still in the for loop, I think. I don't think we have to specify to return that if I is equal to 2 after the first I is equal to 2, then we return true. Otherwise, we return false. I don't think we have to say otherwise return false, because that's sort of implied it was false to begin with. So if this is not true, then obviously the only other value is false. So I think if we do this here, we'll still get all greens. Okay, cool.